Okay, I'm back, and so I just wanted to keep track of all the letters that we're dealing with here, so that we've got distance, which is going to be the letter R, and it's going to be in meters, and then we've got velocity, which is going to be the letter V, and it's in meters per second. So now we want to talk about the concept of acceleration, and so on your car, you have a device called the accelerator. So it's your gas pedal. So when you press on the accelerator in your car, what does it make your car do? Okay, it makes it go faster. So another name for that would be your speed changes. You're going at a certain speed, you hit the gas pedal, and now you're going at a different speed. So a acceleration changes your speed. And so notice that our formula here is A for acceleration. And again, we could do average acceleration. And it's going to be equal to the change in velocity divided by time. So you might have thought that it should be V divided by T, because when we did velocity over here, it was R divided by T. Well, it's very important here that we put this triangle. So the triangle means your change in your speed. So another way of writing this then would be, we're going to take our final speed minus our initial speed and then divided by T. So this way of writing it is exactly the same as this way up here. So what an acceleration is going to do is it's going to change your speed. Now let's look at the units. So the units for speed was going to be meters per second. And then the units for time were going to be seconds. So if we take meters per second, the two S's will go together, and then you're going to get meters per second squared. So that's the official metric unit for acceleration. So here's a math problem for you. A car is initially going at 10 meters per second, and then it accelerates at 7 meters per second squared for 5 seconds. What is its final speed? So we're given the initial speed, we're given the acceleration, we're given the amount of time, and what we don't know is what's the final speed. So we're going to write down our formula, and then we're going to plug numbers into the formula, and notice that this time we don't know what this one is. We don't know what the final velocity is going to be. So now we have to use algebra on this. We need to take the t over to the other side of the equation, and we're always going to do opposites. So if this is our acceleration, what we're going to do is, since this t down here is division, then we're going to multiply. We're going to do the opposite thing. So we're going to multiply both sides of the equation by the letter t, but we're still not finished, because now we need to get this v over to the other side. And so this is a minus, so the opposite of a minus is a plus. So we're going to add it to it. And so we're going to end up with a final speed of 20. Now, don't forget to put the units on there. So the official metric unit for speed is the meter per second. So there's an example of how we would use this formula. And so here are some typical accelerations for objects in meters per second squared. All right, let's take a break. When we come back, we'll talk about sign conventions for distances, speeds, and accelerations.